We, as scientists, have been given this incredible script, the script of nature or of God, if you will. We have this incredible presence. Scientists may be on the verge of uncovering a hidden force of nature, and quantum computers could be the key to unlocking it. For 4 decades, physics has been guided by the Standard Model, which explains the fundamental forces that govern reality: gravity, electromagnetism, and the strong and weak nuclear forces. But now, recent quantum experiments have revealed anomalies that defy current theories, suggesting the presence of an undiscovered force, one that could reshape our understanding of the universe. Quantum computers are unlike anything humanity has ever built. Unlike classical computers, which calculate in strict sequences of zeros and ones, quantum processors can simulate entire systems simultaneously using superposition and entanglement. This allows them to model interactions at an atomic and even subatomic level, exploring physics in ways traditional methods never could. Now, researchers are detecting strange, unexplained patterns, fluctuations in their data that don't fit within the current laws of physics. Some believe these could be early clues pointing toward a fifth fundamental force, something that has long been theorized but never proven. This discovery aligns with what Brian Keating, an esteemed physicist, has discussed for years. He has spoken about gaps in the Standard Model, suggesting that unknown forces or particles could exist beyond our current observations. Could this be the missing piece that finally completes our understanding of reality? We cover the latest breakthroughs in physics and quantum computing, so if you're fascinated by discoveries like this, make sure to subscribe. Why might quantum computers reveal a new force? Classical computers have long been the backbone of scientific discovery, but when it comes to simulating the complex interactions of quantum mechanics, they fall short. The fundamental forces that govern the universe, gravity, electromagnetism, and the strong and weak nuclear forces, operate at scales so small and with such unpredictability that traditional computers simply can't process the sheer complexity of their interactions. This is where quantum computers come in. Unlike classical computers that process data in a sequential manner, quantum processors can simulate multiple outcomes at once, allowing them to model the fabric of reality itself at an unprecedented scale. By analyzing quantum interactions in real time, researchers can explore the deepest mysteries of physics, including forces that may have remained hidden until now. Recently, these quantum simulations have revealed patterns that don't align with the Standard Model of physics. Some of the calculations suggest anomalous interactions, forces that shouldn't exist under current theories but keep appearing in experimental results. Could this be evidence of a new force, one that subtly interacts with reality in ways we never predicted? If true, this could be one of the most groundbreaking discoveries in modern physics, providing the missing link between quantum mechanics and general relativity. Brian Keating has dedicated years to studying cosmology and the biggest unanswered questions in physics. As a leading voice in astrophysics, he has repeatedly pointed out the gaps in the Standard Model, areas where our current understanding of the universe simply doesn't add up. While the Standard Model explains the fundamental forces and particles that shape reality, it fails to incorporate gravity and doesn't account for dark matter or dark energy, which make up the vast majority of the cosmos. Keating has long speculated that undiscovered forces or particles might exist, interacting with reality in ways we haven't yet observed. Now, with quantum computing allowing us to probe the quantum world like never before, researchers are detecting anomalies that don't fit within existing theories. Could these breakthroughs be revealing one of the missing pieces Keating has been discussing for years? If so, this discovery wouldn't just expand our knowledge, it would reshape our understanding of the universe at the most fundamental level. A new force of nature would challenge everything from particle physics to astrophysics, potentially offering a key to solving some of the greatest scientific mysteries of our time. The strange quantum effects that scientists can't explain are only the beginning. Quantum simulations have begun producing unexpected results, challenging the foundations of modern physics. In multiple experiments, researchers have observed anomalies that cannot be explained by the Standard Model, the framework that describes the known forces and particles in the universe. These deviations suggest that there may be an unaccounted-for force subtly influencing reality, something that has eluded detection until now. Some physicists believe these anomalies could be early evidence of a new fundamental force, one that interacts with reality in ways we've never seen before. Others speculate that these results may be linked to dark matter, the mysterious substance that makes up most of the universe yet remains invisible. Another possibility is that these quantum effects hint at hidden dimensions, suggesting that the structure of reality is far more complex than we currently understand. Quantum computing is revolutionizing our ability to test these theories, allowing scientists to simulate conditions at the quantum level with unparalleled precision. Unlike classical experiments, which are limited by physical constraints, quantum processors can explore extreme scenarios, pushing physics beyond its known limits. With each new test, we get closer to uncovering whether these strange quantum effects are glitches in our understanding or signs of something profoundly new. Could this be a fifth fundamental force? For 4 decades, the Standard Model of physics has described the fundamental forces that govern the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These 4 forces explain nearly everything we observe in nature, from the way planets orbit stars to the interactions between subatomic particles. But for years, physicists have suspected that something is missing, a possible fifth fundamental force that has yet to be confirmed. The idea of a hidden force isn't new. Theories like dark energy, which seems to be accelerating the expansion of the universe, suggest that an undiscovered interaction might be shaping reality on a cosmic scale. But despite decades of searching, no direct evidence has been found, until now. Recent quantum computing experiments are hinting at unknown interactions, forces that don't fit within the Standard Model and might be operating in ways we never imagined. If confirmed, this would be one of the most important discoveries in modern physics, rivaling the detection of the Higgs boson in 2012, the so-called God particle, that explains how other particles acquire mass. A fifth force could fundamentally reshape our understanding of the universe, bridging the gap between quantum mechanics and general relativity and providing new insight into dark matter, gravity, and even the fabric of spacetime itself. How close are we to proving this force exists? For years, experiments at CERN and other top research labs have been searching for force-related anomalies, unexplained interactions that could hint at a fifth fundamental force. While some deviations have been observed, no experiment has been able to definitively confirm its existence. However, with the rise of quantum computing, researchers now have a powerful new tool to investigate physics at the most fundamental level. Quantum computers can simulate and analyze atomic and subatomic interactions with precision that was previously impossible. Unlike traditional experiments, which require massive particle accelerators and years of data collection, quantum simulations can rapidly test thousands of theoretical scenarios, exposing inconsistencies in our understanding of physics. If this force exists, quantum computing may be the breakthrough technology that finally proves it. Some scientists believe we may be within the next decade of getting real answers. If confirmed, this force could revolutionize modern physics, not just in theory but in practical applications as well. What does this mean for the future of science? If this hidden force of nature is real, it could mark the beginning of an entirely new era in physics, one that goes beyond Einstein's relativity and the Standard Model. For over a century, physics has been divided between the macroscopic world of gravity and relativity and the microscopic world of quantum mechanics. A newly discovered force could serve as the missing link, unifying these seemingly separate realms and providing a deeper understanding of the universe's structure. Beyond theoretical physics, this discovery could revolutionize technology in ways we can barely imagine. If this force can be harnessed or manipulated, it could lead to next-generation quantum computing capable of solving problems far beyond the reach of today's supercomputers. It might even hold the key to interstellar travel, enabling spacecraft to navigate space in ways we once thought impossible. The future of physics may depend on what we uncover next. This is just the beginning. As experiments continue, we may be on the brink of a discovery that changes everything.